Settle in and let your breathing slow, because the ground under you is about to stop pretending it is stable. You think you are standing on solid earth. Wrong. You are standing on a thin, crunchy skin of salt and clay, laid over a planet that is quietly working the night shift. In the Danakil Depression, the air feels like warm breath that never quite leaves. The colors look unreal. Chalk white flats, sulfur yellow crusts, rust red stains, like the earth spilled its chemicals and never cleaned up. Tonight, with the Sleepless Geographer, you will drift through places that are too hot, too dry, too sharp, and somehow still calming once you stop asking them to be kind. You are here because the earth forgot to be polite. The Danakil is not a normal lowland. It is a tear in the continent, part of a long seam where Africa is being pulled apart, slowly, stubbornly, without drama. And right now, you are stepping onto the seam itself. The surface under your boots looks firm from a distance. It photographs well. It pretends to be a clean, flat floor. But up close, it is crust, salt crust, clay crust, a skin that can crack with a sound like dry bread snapping. In some places, it is strong enough to hold you. In other places, it is a thin promise over hot mud. The air presses against you, not like wind, more like weight, the kind of heat that does not surge and fade, but simply stays. It is steady, like an old radiator humming in a corner you cannot reach. Congratulations, you have found one of the most inhospitable basins on the planet. It is below sea level. It is blisteringly hot for long stretches of the year, and it is filled with chemistry that wants to peel you like a label. And still, people come here to work. You watch them in the distance first, small shapes moving across white flats with a patience that looks almost unreal. Salt miners, salt cutters, they walk as if the land might complain if they hurry. They take axes and simple tools, and they break the crust into neat rectangles, like tiles being lifted from a floor. This is salt, but it is not the gentle table kind, poured from a shaker. This is salt as geology. Salt that crystallized from evaporated water, laid down in sheets, then buried, then lifted, then exposed again. Salt that remembers ancient seas, even when there is no sea for hundreds of miles. When you crouch down and touch the ground, your fingers come away dusty. The crystals are sharp at the edges. The surface is bright enough to make you squint, and the glare feels like it is coming from below you. The sun does not just shine on the Danakil. It bounces. It ricochets off the flats and climbs back into your eyes. You think the landscape is empty. Wrong again. It is busy, just not with the kind of life you prefer. It is busy with evaporation, with minerals precipitating out of shallow brines, with gases escaping through vents. It is busy with the slow labor of the earth, sorting its ingredients into layers. The colors are the giveaway. That yellow over there is sulfur, or sulfur-stained crust. That greenish tint might be copper compounds, or algae clinging to life in water that tastes like a laboratory accident. The reds and browns are iron oxidizing, the planet quietly rusting in real time. You keep walking, and the ground changes texture every few steps. Hard crust becomes brittle crust. Brittle crust becomes lumpy salt. Lumpy salt becomes mud that is dried into curled plates, like the land is shedding skin. And the smell shifts too. Sometimes it is just dust and heat. Sometimes It is sharp, like a cleaning product left open in a small room. That is the Earth venting gases, sulfur compounds, bits of volcanic breath seeping up through wet ground. You are not standing near a single volcano like a postcard cone. You are standing on a whole region that is being stretched thin. The heat is not only from the sun, it is also from below. Geothermal warmth leaking up through fractures because the crust here is not thick and confident. It is thin and tired. When the wind pauses, the silence is not peaceful. It is blank. You hear your own movement too clearly. You hear salt crunch. You hear fabric scrape. You hear the small, embarrassed sounds your body makes when it works too hard in hot air. And then you look up. At night, the Danakil can give you the kind of sky that feels unfair. Stars look closer when the air is dry. The desert does not hold much moisture, so there is less haze. The darkness becomes deep and clean, and the Milky Way looks less like a concept and more like a spill of pale dust. It is almost kind in its way, as if the land is trying to distract you from what is happening under your feet, because beneath the crust, the story is not calm. It is just slow. The Danakil sits near a place where three tectonic regions meet, where the Earth is tugging in different directions. Imagine two shopping carts in a parking lot, rolling toward each other at a pace so slow you could fall asleep watching. Now imagine the carts are continents, and the collision takes millions of years. Except here, it is not a collision. It is a pulling apart. This is a rift zone, a place where the crust is being stretched, like fabric pulled tight. It does not rip all at once. It thins. It cracks. It sags. It makes room for hot material from deeper down to rise closer to the surface. That is why the ground feels wrong. Not haunted, not cursed, just unfinished. When you see a straight valley cutting across the landscape, that is not a coincidence. Rivers can carve winding shapes, but straight lines, long, stubborn lines, are often the fingerprints of faults, cracks in the crust, places where one side moved relative to the other, not because it wanted to, but because the planet's interior insisted. You do not feel the plates moving under you, not in any daily way. The motion is too small, too patient. It is like watching an hour hand shift, but the results are everywhere. Fresh fractures, tilted blocks of land, areas where the crust dropped down and created a basin, like a slow collapse of a ceiling. The Danakil Depression is, in part, one of those dropped areas, a place that sank as the crust stretched, then filled with sediments and salt and volcanic material. Over and over, the region has been flooded and dried, flooded and dried. Water arrives, water leaves. Salt stays. That is the rule. And the land keeps changing faster than you would expect, at least by geological standards. Not fast like a storm, fast like a landscape that is constantly being rearranged by heat, brine, and the occasional rare rain. When rain does fall, it does not behave politely. It runs across hard crust and collects in shallow basins, dissolving minerals, and then evaporating again. The salt reorganizes itself afterward, crystallizing into new patterns. It is like the land is constantly rewriting its own surface, using the same ingredients in different arrangements. You might think of continents as furniture, stable, set in place, something you can build on and forget. But out here, the continent feels more like a raft, a big, slow raft, cracking along its seams. There is a quiet humility in that, if you let it in. Your life is full of deadlines and tiny alarms. The Earth does not care. It is stretching a continent apart on a schedule so long, it does not even bother calling it a schedule. You keep walking, and you find a place where the crust is broken into plates, each one edged with salt crystals. The gaps between them are dark. You do not have to touch them to know they are softer. The ground is telling you gently to watch your step. In the distance, the air shimmers. Heat haze makes the horizon wobble. It looks like water sometimes because your brain likes hope. Your brain sees a mirage and tries to turn it into rescue. But the Danakil does not do rescue. It does reality. Humans survive here anyway because humans are stubborn animals with a talent for routines. Salt is valuable. It preserves food. It travels. For centuries, caravans moved salt across the region. Blocks stacked like pale bricks, loaded onto camels that learned the patience of deserts. The work is repetitive, almost meditative, if you are not the one doing it. Chop, lift, stack, walk. The men and animals move across the flats in slow lines. The land watches without opinion, and you realize something uncomfortable. This place is not empty because nothing can live here. It is empty because life here must be small and careful and adapted. It cannot waste water. It cannot waste energy. It cannot demand comfort. The Danakil is an extreme environment, but it is also a simple lesson. The Earth gives you conditions. You either match them or you leave. And speaking of conditions you cannot negotiate with, you start listening for the deeper sound under the crust. Not a roar, not an earthquake movie rumble, more like a low, constant suggestion that the planet is pulling itself apart. You move toward a zone where the ground looks fractured, long cracks, low ridges, jagged edges that run like seams through the flats. This is where rifting becomes visible, where the crust has opened and healed and opened again. A rift is not just a crack, it is a process. The crust is being stretched, and in response, it breaks into blocks. Some blocks drop down, some tilt. Magma from below can rise into the fractures, cooling into new rock. The continent is not just splitting, it is being rebuilt as it splits. That is the part people forget. Destruction and construction happen together. The Earth does not do clean endings. It does messy transitions. If you could speed up time, the landscape would twitch. Cracks would lengthen. Small faults would slip. New vents might open after a swarm of tiny earthquakes. Not the dramatic kind that throws you off your feet. More like the crust adjusting its posture in the night. You might see a fresh line in the salt flats where the ground shifted by the width of your hand. You might find a ridge that was not there last season, pushed up by movement along the fault. In rift zones, the land is always slightly newer than your map. And because the crust is thinner here, heat can travel upward more easily. That is why you find warm spots in the ground, places where the air feels even hotter close to the surface, as if the land is exhaling. Sometimes there are small vents, openings where steam and gas escape. Sometimes there are pools fed by hot, mineral-rich water. Sometimes there is just a patch of ground that refuses to cool, even after the sun goes down. This is the planet's interior, not far below, not close in a way you can touch, but close in a way you can sense, like a radiator behind a wall. And if you stand still long enough, you start to understand that continents are temporary. They are arrangements. They are chapters. The rift is the beginning of a new chapter, one that may, in deep time, become an ocean basin. The Red Sea exists because of rifting. The Gulf of Aden exists because of rifting. Stretch long enough, thin enough, and eventually the crust breaks completely. Water moves in. New ocean crust forms. A seam becomes a gap. A gap becomes a sea. It is almost soothing in a strange way. The Earth has done this before. It will do it again. You are just catching it mid-process, like walking in on someone renovating their house and pretending it is still tidy. Of course, humans build here anyway, in the broader region. Roads cross fault zones. Towns sit near geothermal fields. People pump water from aquifers that took thousands of years to fill. We live on moving ground and act surprised when it moves. But the rift does not care about surprise. It cares about physics. Rock under tension breaks. Heat rises. Fluids move through fractures. Minerals precipitate out of solution. Salt rearranges itself. Repeat. And then, as you walk along the edge of a fractured area, you notice something that looks like water in a shallow bowl. It reflects the sky in a way that feels almost gentle. From far away, it could be inviting, a mirror in the desert. But you have learned by now not to trust the first impression. And speaking of lakes, some waters look peaceful from a distance, right up until you realize they are the kind that punishes curiosity. You approach slowly because the edges are strange. The shoreline is not sand. It is crust, white, brittle, and scalloped, like foam frozen in place. The surface of the water is still, but it is not the calm of safety. It is the calm of something dense and heavy. This is brine, water loaded with salt and minerals, often far saltier than the ocean. The kind of water that does not want to share space with life, except for a few specialists that have given up on comfort entirely. If you dip a finger in, it comes out slick. Your skin feels tight almost immediately because salt is greedy. It pulls moisture. It reminds your body rudely that you are mostly water and you would like to keep it. In very salty lakes, floating is easy. The water holds you up like a firm hand. It can feel like a kindness for about 10 seconds. Then the salt starts to sting any tiny cut you forgot you had. Your lips dry out faster. Your eyes water if you rub them. The lake gives with one hand and takes with the other. Some pools out here are not just salty, they are acidic or hot or rich in minerals that tint them unnatural colors. Green, orange, milky white, rust red. They look like spilled paint, like a palette left out under the sun. The chemistry depends on what is rising from below and what is dissolving from the rocks around it. Sulfur can make things yellow. Iron makes reds and browns. Other minerals create blues and greens that look like tropical water. Until you remember, tropical water does not usually smell like a battery. The air above some pools carries a sharp bite. Your nose recognizes it as wrong, even if you cannot name it. It is the smell of the earth venting through wet ground, gases dissolving into water, changing the chemistry, making a place where only the hardiest microbes feel at home. Those microbes are not dramatic. They do not roar, they do not wave, they simply exist, quietly converting chemicals into energy, living in conditions that would make your cells panic. It is humbling and a little insulting. Life finds a way, people say, but they mean life finds a way for us. Out here, life finds a way for itself, and you are not invited. You step closer and notice the crust near the edge is thin. It has cracks like spider webs. You could break through it with a careless footstep. Underneath might be soft mud, or warm brine, or a layer of salt that gives way like rotten ice. This is not a place for running. Not that you would run in this heat anyway. This is a place for slow, deliberate movement, for watching where you put your weight, for accepting that the ground is sometimes lying. The pools can be shallow, and that makes them feel less threatening. Shallow water looks manageable. You can see the bottom. You think you understand it. But shallow brine is often the most deceptive. Sunlight heats it quickly. Evaporation concentrates it quickly. Crust forms quickly, and the surface can look solid in patches, like a floor. It is not a floor. It is a lid. And in places like this, the planet makes lids the way it makes everything else, imperfectly, and without regard for your plans. So you keep your distance and you watch instead. You watch tiny ripples move across the surface when a faint breeze passes. You watch mineral crystals at the shoreline glint like broken glass. You watch the colors shift as the sun angle changes, as if the lake is trying on different disguises. You think about water as something gentle, something that soothes, something you drink when you are thirsty. Here, water is not gentle. It is a chemical tool. It dissolves, it concentrates, it stings, it preserves, it kills. It is still water technically, but it has been recruited into the geology. And the longer you look, the more you notice a pattern. Water goes where it can. It fills low spots. It moves through cracks. It carries minerals. Then it leaves again, taken by sun and air. The minerals stay behind, building crusts, building layers, building the illusion of permanence. It is the same basic process that made salt flats all over the world, from high deserts to coastal basins. Water arrives with stuff in it. Water evaporates. Stuff remains. Repeat until the land shines white and your skin feels like paper. Out here, the schedule is simple. Day heats, water evaporates, night cools, crust tightens, the rift pulls, the earth exhales. And after you spend enough time around water that behaves badly, you start to appreciate a different kind of water. Water that does not sit and concentrate. Water that moves. Water that can be harsh in its own way, but at least has the decency to keep going. After all, a river does not pretend to be a mirror. It admits what it is. A one-way trip. A one-way trip paid for in gravity and charged interest in sand. You stand on a riverbank that looks calm enough to fool you. For a moment, the surface slides past with that smooth, practiced confidence. It does not splash unless it has to. It does not announce itself unless the channel narrows or the rocks argue back. From a distance, it is almost restful. A long ribbon, a quiet line. Up close, you notice what the river is really doing. It is carrying pieces of somewhere else. Tiny grains that used to be part of a mountain face. Dark flecks that were once a basalt flow, cooled and cracked. Pale dust that was once a limestone ridge, now reduced to something you could wipe off your fingertips. A river is not a place. It is a process you can stand next to. And if you listen carefully, you can hear the work. Not a single loud sound, but a constant, faint grind. Sand rolling along the bottom. Pebbles clicking together like teeth. Water pushing, always pushing, with the patience of something that has no deadlines. You think the river is here to decorate the landscape. Wrong. The river is here to rearrange it. The current grabs at the bank where it can. It undercuts the edge just enough. Then gravity does the rest. A slice of soil slumps in, grass and all. And the river takes it like a receipt. You watch the collapse happen quietly, almost politely. No drama. Just a simple transfer of ownership. This is how valleys widen, not with one grand event, but with thousands of small surrenders. And you are part of it now. You are a grain of sand, the kind nobody cares about until it is in their shoes. You begin your journey in the high ground, where rock breaks under frost, heat, and time. You tumble into a creek, then a stream, then something wide enough to have a name on a map. At first, the ride is rough. The slope is steep. The water is fast, and it treats you like baggage it did not ask for. You bounce along the bottom, striking other grains, other stones, chipping corners off yourself. Geologists call this abrasion. In human terms, it is being slowly sanded down by a world that never stops moving. As the river goes on, it sorts you. Big pieces drop out first. Smaller pieces travel farther. Clay can stay suspended for ages, turning the water the color of coffee with too much milk. The river is a conveyor belt with opinions. It decides what moves, what settles, and when. You start to notice the channel shape changing. In the upper reaches, the river cuts down. It makes a narrow valley, steep walls, sharp angles. Water here behaves like a person in a hurry. It takes the most direct path downhill, and it does not linger. Farther along, the slope relaxes. The river stops cutting straight down and starts wandering. It swings side to side, lazily at first, then more confidently. Carving bends called meanders. The outside of each bend erodes. The inside collects sediment. One side is demolition, the other side is construction. It is a strange balance, like the river is both destroying and building, and never considers that contradictory. You stand on a bend and watch the water chew into the far bank. The soil there is darker, damp, heavy with roots. Trees lean slightly toward the channel, as if they are listening. That lean is not poetic. It is panic, stretched over years. They are being undermined, slowly, until one storm, one high flow, makes the decision for them. Congratulations. You have found a place where land is temporary. Humans love drawing lines along rivers, borders, property boundaries, municipal edges. We behave as if the river is a reliable penstroke. But rivers rewrite themselves. Meanders migrate. Channels jump. Whole bends get cut off in a flood, leaving oxbow lakes behind. Crescent-shaped ponds that look peaceful and are really just abandoned parts of a former river. Maps try to keep up. The river does not notice. And floods are not the river misbehaving. Floods are the river being honest. When rain comes hard upstream or snow melts too quickly, the river rises. It climbs out of its channel like a tired animal standing up. It spreads across the floodplain, that wide, flat area that always looks like such a good place to build a town. It is flat for a reason. Floodplains are made by floods over and over, laying down layers of silt and sand like thin blankets. Each flood adds a little more. Each flood smooths the land further. The soil becomes rich, easy to farm, a perfect trap for human optimism. So humans move in. We plant, we pave, we build things with basements. Then we act offended when the river returns to the space it carved for itself. The river does not hold grudges. It does not punish. It simply follows physics, and physics has no sympathy for mortgages. Even when the water level drops again, the evidence remains. Fresh sediment over roads, driftwood tangled in fences, a strange new bar of sand where there used to be a clean curve. The river has rearranged the furniture, and you can either accept it or spend the rest of your life trying to nail it down. Some rivers carry their stories in their color. A glacial river can be pale and cloudy, full of rock flour, tiny particles ground by ice until they are so fine they stay suspended. A desert river can be muddy and sudden, running only after storms, dry most days, then roaring with brown water that smells like wet dust. A tropical river can be dark, stained by tannins from leaves and soil. The color of tea steeped too long. It looks gentle, almost soft. And then you remember it is moving entire trees without asking permission. Every river is a compromise between climate, slope, and stone. And all of them are doing the same quiet job, moving the continents downhill. You keep following the current in your mind, downstream, downstream, until the river slows enough to start dropping its load. It can no longer carry everything. The energy fades. The channel splits into smaller threads. Sand and silt settle out in fans and lobes. This is how deltas form. The river arrives at a standing body of water, a sea or a lake, and it loses its nerve. It spreads out. It dumps sediment. Over time, it builds land outward, a slow extension of the continent into the water. Deltas are some of the most fertile places on Earth. They are also some of the most unstable. The ground is young, soft, waterlogged. It compacts. It sinks. Channels shift constantly. If sea level rises, the delta can drown. If dams upstream trap sediment, the delta starves. Humans love deltas anyway. We pack them with cities, farms, ports, roads. We build on land that is still being assembled, grain by grain. And then we act surprised when it behaves like unfinished work. You can almost admire the confidence. And then you remember something else. Rivers do not just carry sediment. They carry dissolved minerals too. Tiny, invisible loads, salts, and ions leached from rock, moved quietly in solution. The river is not only a truck full of sand, it is also a chemical courier, delivering ingredients to the ocean, changing the chemistry of seas over time. It is all connected. Mountains weather, rivers transport, oceans receive. But rivers are not the only long-distance movers of Earth's material. When the planet gets cold enough, water stops acting like water and starts acting like a bulldozer. Because if a river is a steady hand, a glacier is a heavy shoulder leaning into the valley until the valley gives up. You arrive at the edge of ice the way you arrive at silence. Gradually, then all at once. The air feels different first. It has a clean bite to it, even if the sun is bright. The wind is sharper, as if it has fewer obstacles to soften it. The sound changes too. Near ice, the world goes quiet in a specific way. Soft surfaces absorb noise. Snow does not echo. It swallows. You look at the glacier and your brain tries to file it under still objects. A frozen lake, a white field, a sleeping thing. Wrong again. A glacier moves. Not fast, not in a way you would notice while standing there, but it moves with the certainty of weight. Ice under its own mass deforms. It creeps downhill the way thick honey creeps across a plate, except colder, heavier, and far less forgiving. You step closer and see that the surface is not smooth. It is cracked, ridged, bruised with gray. Those cracks are crevasses, deep fractures where the ice has stretched too quickly over uneven ground. Some are narrow enough to step over if you are foolish. Some are wide enough to swallow sound. If you toss a pebble into one, you might wait longer than you like for the faint tick at the bottom. That delay is not suspense. It is depth. Congratulations, you have found a landscape that can hide a hole under a dusting of snow and call it natural selection. The glacier's color changes with angle. In shadow, it can look blue, a dense, clear blue that feels unnatural in a world of white. That blue comes from the way ice absorbs light. The red and yellow wavelengths get eaten first. The blue survives. It is not magic. It is physics. Doing aesthetics? Along the edges, you see dark stripes and patches. This is debris, rock, and dirt carried by the ice. Some of it fell from valley walls. Some of it was plucked from the ground below. A glacier is not clean. It is a moving mix of ice and stone. And that stone is the point. As the glacier slides, it grinds. The rock beneath gets scraped, gouged, polished. The glacier leaves striations, long scratches carved into bedrock, showing the direction of flow like claw marks. It also leaves rock flour powder so fine it turns meltwater milky. When you stand near a meltwater stream, you see that pale color and you realize that glacier has been sanding a mountain into dust. A river cuts like a saw in one narrow line. A glacier presses like a palm, broad and heavy. That difference shapes the valleys. River valleys tend to be V-shaped, narrow at the bottom, steep walls. Glacier valleys are U-shaped, wide and open, as if the land has been scooped out with a massive spoon. You can stand in one and feel the scale in your bones. The walls rise smooth and high. The floor is broad. The whole valley looks oversized for the stream that now trickles through it. That small stream is what remains when the glacier retreats. The valley is an empty mold, still holding the shape of something larger, and the glacier is always leaving gifts behind. Moraines, piles of debris pushed and dumped at the edges in front of the ice. They look like messy ridges of rock, unorganized, raw. That is because glaciers do not sort sediment the way rivers do. They carry everything together and drop it together. It is a landfill made by nature. When the ice melts, it can leave lakes behind too, water-filling depressions carved by ice or dammed by moraines. Some of these lakes are startlingly blue, fed by glacial melt and suspended rock flour that scatters light. They look like postcards. But remember, they exist because something huge and heavy used to live here, and now it is gone. In summer, meltwater roars, streams swell, water runs across the glacier surface in little channels that shine under the sun. Then it finds cracks, molens, vertical shafts that swallow water and drop it into the glacier's interior. The water disappears with a sound like pouring into a deep drain. Down inside, meltwater can lubricate the base, helping the glacier slide faster for a time. So the glacier responds to warmth in an unintuitive way. Heat can make it move more quickly, even as it shrinks. Then winter comes back and the surface quiets again. Snow covers old cracks. New snow compresses into fern, then into ice over years. The glacier is a memory machine. Each layer holds a record of seasons, storms, dust, and distant eruptions. Scientists drill ice cores and read them like diaries. Air bubbles trapped inside hold ancient atmospheres. Tiny bits of ash mark volcanic events. Changes in isotopes track temperature shifts. The glacier has been recording the world while humans have been busy inventing reasons not to listen. But glaciers are not just archives. They are hazards with good lighting. When ice sits on a steep slope, it can fail. Seracs, those tall, jagged towers of ice, can collapse without warning. Avalanches can release slabs that accelerate instantly. Glacial lakes can burst when their natural dams weaken, sending floods downstream that arrive like an ambush. And yet, people live beneath glaciers. They farm in valleys carved by ice. They drink meltwater. They build towns where the soil is glacial, till unstable but workable. The glacier provides and threatens at the same time, like an old patron with a temper. In some regions, as glaciers retreat, they expose raw ground that has not seen sunlight in thousands of years. Fresh rock, fresh soil, fresh opportunity. Plants move in slowly, mosses first, then grasses, then shrubs. Ecological succession, the slow repopulation of newly opened space. It looks hopeful until you remember why the ice retreated in the first place. But deep time has no villains, only causes and effects. Climate shifts, ice advances, ice retreats, sea level rises and falls. Mountains are carved, new soils form. Humans arrive late, build quickly, and panic when the background process continues. You follow the meltwater downstream and feel the transition. The air warms, the stream grows, it picks up sediment and becomes a river again, carrying glacial flour and stones toward lower ground. And eventually, all of it goes to the sea. The ocean is not a destination. It is a collection point, a giant basin, catching whatever gravity delivers. You reach the coastline, and the first thing you notice is that it refuses to sit still. Even if the land looks solid, even if the sea looks calm, the boundary between them is always in motion. A coastline is not a line. It is an argument that never ends. Waves roll in with the casual repetition of a thought you cannot get rid of. They rise, curl, break, and retreat. Then they do it again and again. And they are not trying to be dramatic. They are trying to be effective. Each wave carries energy. The wind gives it to the water, sometimes from far away, building swells that travel across whole oceans. By the time they reach shore, they have a purpose. They find weak spots in rock. They exploit cracks. They force air into little holes in cliffs, compressing it like a piston. The pressure pops fragments loose. Salt water seeps into fractures and leaves salt crystals behind when it evaporates, and those crystals expand, prying rock apart grain by grain. Coastal erosion is slow violence, the kind that looks gentle until you compare old photographs. You stand near a cliff and see the base undercut, a notch carved by waves where the rock has been eaten away. Above it, the cliff face hangs forward slightly, unsupported, pretending it is stable. It is not. One storm, one season of heavy surf, and a slab can collapse. Tons of rock drop in a single moment, and the shoreline jumps landward by a few meters. The sea takes the rubble and starts grinding it into smaller pieces, turning cliffs into boulders, boulders into cobbles, cobbles into sand. This is why beaches exist, not because the coast is peaceful, but because something is always breaking. A beach feels soft under your feet, but it is really temporary storage. Sand is not loyal. It arrives with waves and currents. It leaves with waves and currents. Storms can strip a beach down to bare rock overnight, then slowly rebuild it over months. Longshore drift moves sand along the coast, grain by grain, as waves approach at an angle and pull back straight. The result is a sideways conveyor belt. Beaches migrate, sandbars form and vanish, inlets open and close. Humans respond by building walls, seawalls, groins, breakwaters. We try to freeze a shoreline in place, as if the ocean will respect our architecture. Sometimes it works for a while in one spot, but the sand that gets trapped on one side starves the other side. Erosion increases elsewhere. The coastline simply moves its argument down the road. Congratulations, you have built a very expensive way to relocate the problem. And the sea itself is never quite fixed. Sea level changes, sometimes because ice melts, sometimes because water warms and expands, sometimes because the land rises or sinks. The ground can lift after glaciers retreat, isostatic rebound, the Earth's crust slowly springing back after being crushed by ice. It sounds like a yoga move. It is the planet adjusting its posture over thousands of years. In some places, the coast is rising, lifted by tectonics. In others, it is sinking due to subsidence, sediment compacting, or fault slipping. Two towns on the same sea can have very different futures. You walk along the shore and find sea caves carved into headlands, dark openings where waves have hollowed out rock. If the cave extends through, it becomes an arch. Arches look like coastal art, elegant and framed against the sky. But they are really the ocean testing a weak spot until it breaks. Eventually the arch collapses, leaving the sea stack, a lonely pillar offshore. Then the stack erodes too, shrinking, cracking, until it becomes a stump, then disappears into the surf. The coastline is always simplifying shapes, sanding down complexity, returning everything to smaller pieces. Even calm coves are not safe from this logic. They just erode more quietly. You notice driftwood, seaweed, and bits of shell gathered in a line above the current tide. That line marks the last high water or the last storm surge. It is the ocean's handwriting on the beach, a reminder that it can reach farther whenever it wants. And behind the beach, dunes may rise, built by wind lifting dry sand and piling it into soft ridges. Coastal dunes can look gentle, grassy, stable, but they are also mobile, and they are also protection. They absorb storm energy. They store sand that can rebuild beaches after erosion. When humans flatten dunes to build closer to the water, they remove the coast's ability to heal itself. Then the next storm arrives, and the ocean walks farther inland, like it was invited. You can trace the whole system now. Mountains weather into sediment. Rivers deliver sediment to the sea. Waves redistribute it along coasts. Wind lifts it into dunes, and all of it is temporary, constantly moving through forms. But if you follow the coast inland just a little, you can feel the air change. Moisture fades, vegetation thins, the softness retreats. The land stops pretending it can support anything that needs regular rain, and the world becomes quieter, not because nothing happens, but because what happens is slow, dry, and patient. You step into a desert that does not shout. It does not need to. The first surprise is that there may be very little sand. Deserts are defined by lack of precipitation, not by dunes. Some deserts are gravel plains, stone pavements, bare rock, wind-carved ridges. Sand is just what happens when there is enough loose sediment and enough wind to keep it moving. Wind is the desert's river. It flows around obstacles, accelerates through gaps, and carries sediment in pulses. Grains hop along the ground in a motion called saltation, little jumps driven by gusts. Each impact knocks other grains loose. It is a chain reaction of tiny collisions. Over time, dunes form where wind loses energy. Behind rocks, in shallow basins, along the edges of vegetation, dunes are not fixed hills. They migrate, reshaped nightly. The crest advances, the slip face avalanches. The whole dune walks across the landscape like a slow animal made of grains. You can stand on a dune at dusk and watch ripples sharpen in the low light. Each ripple is a record of recent wind, like fingerprints pressed into sand. By morning, the pattern may be gone, replaced by a new one. The desert is constantly being erased and rewritten. Heat does its own kind of erosion too. In deserts, rock expands during the day and contracts at night. This thermal stress can crack surfaces over time. Layers peel off like flaking paint. Boulders split. The process is slow but relentless, like a bad habit the planet refuses to quit. And when rain does come, it is often rude about it. Water hits hard ground that cannot absorb it quickly. Dry channels called arroyos or wadis fill suddenly. Flash floods surge through, carrying debris, carving banks, moving boulders that look immovable. Then, just as suddenly, the water vanishes again, sinking into sand or evaporating, leaving behind fresh scars and rearranged stones. The desert does not get many chances to use water, so it uses them aggressively. Life adapts by doing less. Plants shrink leaves, grow spines, store water, or send roots deep. Animals hide during the day and move at night. Some species wait as seeds for years, then bloom after rain in a brief, almost spiteful explosion of color. The desert's strategy is patience. Save everything, waste nothing. Wait for opportunity. And at night, the temperature drops fast. Without clouds to trap heat, the ground radiates warmth into the sky. The same dryness that made the stars sharp now makes the cold feel unfair. The day used all the warmth and left none behind. You pull your collar tighter and realize the desert is not one environment. It is a swing, a daily cycle of heat and cold, exposure and shelter, glare and darkness. In some deserts, salt crusts form again in basins, remnants of ancient lakes. In others, wind sculpts rock into yardangs, long ridges aligned with prevailing winds, as if the land has been combed. Dust storms lift fine particles and carry them far beyond the desert's borders, fertilizing distant oceans and forests. Even emptiness travels. But if you keep walking through dry air long enough, you begin to feel the temptation to blame the sun for everything. The heat, the dryness, the harshness. It is an easy villain, hanging there in the sky like a spotlight. And then you remember the other heat source, the one beneath your feet, the one that never sets, because some places on Earth are not warmed from above. They are kept awake from below, and you start to notice it first in small ways. A patch of ground that feels warmer in the cool night, a faint smell of minerals, a thin thread of steam rising where it should not, the land giving you gentle hints, like tapping on a wall, to show you the room behind it. You follow those hints into volcano country, where the floor is not entirely trustworthy. A volcano does not always look like the classic cone with smoke and drama. Sometimes it is a broad shield, a low dome that takes up the horizon without seeming tall. Sometimes it is a field of vents and fissures, cracks that ooze lava along a line instead of exploding from a summit. Explosive volcanoes get the headlines, but effusive volcanoes are the ones that really show you the planet's mood. They leak, they spill, they spread. Lava can move like a slow glowing river, its surface cooling into a dark crust while the inside stays molten. From a distance, it looks solid. Up close, it moves, folds, and breaks, making sounds like glass settling. The crust forms wrinkles, ropey textures called pejejo, like the earth trying to knit itself a blanket. Other lava flows are rougher, sharper, broken into jagged clinkers called AA. Walking on it feels like stepping on a pile of broken ceramics. It tears shoes. It punishes ankles. It is not scenic when you are inside it. Volcanoes build land quickly, but they do it with material that starts fragile. Fresh basalt weathers into soil over time, rich in minerals. That is why people farm volcanic slopes. The ground is fertile, dark, eager to grow things. The price tag is that the volcano is not dead. It is just quiet. Steam vents, fumaroles, and hot springs are the gentle warnings. Water percolates down through cracks, heats up near magma, rises again carrying dissolved minerals. It emerges hot, sometimes acidic, sometimes staining the ground in bright colors, painting rocks with sulfur yellows and iron reds. It looks beautiful in a way that feels slightly unsafe, because it is. The gases can include sulfur dioxide, carbon dioxide, and other compounds that do not care about lungs. In low spots, heavier gases can pool, invisible. Animals can wander in and collapse without struggle. Humans have to learn, sometimes the hard way, that air is not always breathable, just because it is there. And there is a deeper tension beneath all of this calm surface detail. Magma is not a lake of fire sitting neatly under a mountain. It is a system of chambers, sills, dikes, and mushy zones of partially molten rock. Pressure builds when new magma arrives, when gases expand, when pathways clog. Sometimes the pressure releases as a slow eruption. Sometimes it releases as an explosion that pulverizes rock into ash. Sometimes it just causes earthquakes, tremors that rattle cups and nerves, reminders that the crust is not a thick, safe shell everywhere. You can stand on volcanic ground and feel how new it is. Black rock with sharp edges, barely weathered, sparse plants trying to root in cracks. A landscape that is still cooling, still settling into itself. And if you shift your view a little wider, you see how quickly volcanoes can create islands. A submarine eruption piles lava and ash until it breaches the surface. A new landmass appears, steaming, unstable, immediately attacked by waves. The ocean begins eroding it as soon as it is born, as if to say, yes, very impressive. Now watch this. Some newborn islands last, some vanish in a season. Most of them spend their lives being built and dismantled at the same time. That is the general theme, if you have not noticed. The Earth is never only creating or only destroying. It is always doing both, just at different speeds. And humans? Humans move into volcanic regions because the soil is good, the scenery is dramatic, and the geothermal energy can be harnessed. We drill wells to tap steam and hot water, turning underground heat into electricity. We build spas around hot springs because nothing says relaxation like bathing in the planet's leaked internal fluids. We name mountains and draw hazard maps. Then we build just outside the zones that look scary on paper. Then the volcano reminds us that paper is not a force field. The quiet part, though, is the waiting. Years of stillness, decades, centuries, enough time for stories to fade into folklore, enough time for a town to become complacent, enough time for the volcano to reload. You walk across a field of old lava and imagine the long patience of cooling rock. Even after an eruption ends, heat can remain underground for years. Hydrothermal systems continue circulating. Minerals keep precipitating. The landscape keeps adjusting. And beneath all of it, deep in the mantle, heat flows upward from Earth's interior, left over from formation, plus heat from radioactive decay. It is a slow burn on a planetary scale, a background engine that never really shuts off. That engine is the reason rifts open, the reason plates move, the reason volcanoes exist along subduction zones and hot spots, the reason mountain ranges rise and then get eroded into plains. Which brings you gently to a thought that is not dramatic, just steady. Landscapes feel permanent only because your life is short. You can stand in a canyon and feel like it has always been there. But the canyon is an act of ongoing erosion, a river cutting down, grain by grain. You can stand on a mountain and feel like it is eternal. But the mountain is a temporary bulge of crust, uplifted by collision or magma, then slowly shaved down by rain, ice, and wind. Even the sea floor is young in many places, constantly recycled. New crust forms at mid-ocean ridges, then moves outward, cools, sinks, and eventually gets shoved back into the mantle. At trenches, the planet is not a museum. It is a factory with no off switch, and extreme places are not mistakes. They are normal outcomes. Salt flats form where water evaporates. Glaciers form where snow persists. Deserts form where air descends dry, or where mountains block moisture, or where cold currents stabilize the atmosphere and prevent rain. Volcanoes form where melt is generated and finds a path. Coasts erode where waves have energy and rock has weaknesses. Everything is cause and effect, stacked like layers in sediment. You, meanwhile, are an organism that prefers comfort, stable temperatures, reliable ground, and predictable water. You are a creature built for a narrow band of conditions. The Earth does not specialize in those conditions. It specializes in motion. But there is something oddly comforting in that indifference. The planet does not hate you. It does not target you. It does not even notice you most of the time. It simply continues cycling through uplift and erosion, freezing and thawing, flooding and drying. A rhythm older than your species and likely older than your concept of rhythm. If you let your mind drift across deep time, you can almost watch continents rearrange like slow clouds. Rift valleys widen, seas open, mountains rise, along collisions, then wear down into low hills, then into plains. Rivers change course. Ice sheets advance, retreat, and leave scratched bedrock and scattered boulders like discarded tools. And you realize the map is not a finished document. It is a temporary screenshot. Even now, somewhere, a cliff is collapsing into the sea. Somewhere, a dune is creeping over a road. Somewhere, a glacier is calving, dropping an iceberg into cold water with a sound like a door shutting in a cathedral. Somewhere, a river is quietly stealing a field, and somewhere beneath your imagined footsteps, magma is moving through a fracture. Not hurried, not angry, just following pressure, following buoyancy, doing what hot rock does when it is given a chance. You hold all these places in your mind at once: salt flats and rift seams, acid pools and patient rivers, grinding ice and arguing coasts, whispering deserts and softly threatening volcanoes. And you keep going, not toward an ending, but deeper into the same endless steady cycle, where the planet keeps working without applause, and the next landscape is already forming in the dark. So you stop thinking in minutes and start thinking in layers. You stand in your imagination on a slab of rock that has no reason to be here, except history. Not human history, the short kind with names and dates, but the longer kind, the kind written in pressure and water and heat. The kind you can only read if you accept that everything you call stable is just slow. And since you cannot follow deep time with your feet, you follow it the way the planet does, with gradients, with downhill, with whatever path has the least resistance. Because deep time is not a straight hallway. It is a set of doors that open when conditions are right, then close again, without explanation. You start with one of the simplest doors. A mountain that rises because plates collide or because hot rock swells underneath. It looks like a monument, like a permanent landmark, but you already know the punchline. Mountains do not win. They get worn down by weather and by ice and by water that keeps showing up. It does not matter if the water is polite. It does not matter if it arrives as fog or drizzle or a hard seasonal rain. If it arrives often enough, it works. Even in places that feel dry, even in places that look like bare stone, water is still doing chemistry. It seeps into tiny cracks and dissolves minerals. It reacts with silicates and turns them into clays, softer, weaker, easier to carry away. Geologists call it chemical weathering. In human terms, it is the slow embarrassment of rock turning into mud. And then there is physical weathering, the blunt side of the process. Freeze and thaw, heat and cool, roots finding gaps and pushing, salt crystals growing inside pores, prying grains apart. The mountain does not need a catastrophe. It just needs time. So, you picture the mountain face shedding little fragments day after day, the way old paint peels. Each fragment is small, almost insulting, until you remember the schedule is endless. Then gravity takes over, because gravity always takes over. Pebbles roll down slope, scree piles collect, a fan of debris spreads at the base, like the mountain is quietly losing weight. And somewhere, a stream catches the pieces and begins the long transport again. This is why, when you look at a continent from far away, it looks like it is melting, not into liquid, but into lower forms. High ground being shaved into low ground, a constant lowering, interrupted only by uplift and volcanism, and the planet's habit of making new problems. You can hold that thought gently. The Earth always lowers what it raises, but lowering is not always simple. Sometimes the planet does something more theatrical and still manages to do it quietly. You arrive at a canyon, not the postcard angle, not the heroic viewpoint with the sun at the perfect slant. You arrive at the edge when the light is flat and the air is still, and you can hear your own pulse. You think you are looking at an empty cut in the earth. Wrong. You are looking at a record of persistence. A canyon is a place where a river was stubborn enough and the land lifted fast enough that down-cutting won the argument. The river stayed in place, in a sense, even as the ground rose around it, like a saw that keeps cutting while someone slowly lifts the wood. That is how you get depth that feels unreasonable. Depth that makes the air below you look darker, heavier, as if it has settled in the bottom like cold water in a basin. From the rim, the river looks harmless. A thin ribbon, sometimes the color of silt, sometimes the color of shadow. Your brain tries to scale it wrong because your brain likes comfort. But the canyon walls tell you the truth. Layer after layer, stacked like pages, each with a different grain, a different color, a different resistance to erosion. Some layers are tough, forming ledges, sandstone, limestone, basalt flows, rock that holds on longer. Other layers are weak, forming slopes, shales that crumble and retreat. The canyon is not carved evenly. It is carved according to what gives up first. And the river, down there, is not cutting only with water. It cuts with whatever it carries. Sand is the blade, gravel is the teeth. During floods, entire boulders can roll along the bottom, knocking into bedrock, making potholes that deepen like drills. The river does not need to be violent every day. It needs to be violent sometimes. It needs those seasonal surges, those rare heavy rains, those snowmelt pulses, because most of the work happens when you are not watching. You can stand at the edge and feel very calm because nothing is moving fast enough to scare you. That calm is part of the trick. The planet prefers slow. And if you climb down into the canyon in your mind, the temperature changes, the wind changes, the light changes, sound narrows. Trapped by walls, you feel smaller, not emotionally, but physically, like the space has reduced your scale. Plants cling where they can, in cracks, on ledges, in places where a bit of soil collects. Life becomes strategic because the rock is stingy, and human life, when it shows up, is always a negotiation. Trails that follow weaknesses, settlements near springs, bridges where the canyon narrows because a wide gap is expensive. You can almost hear the excuses we tell ourselves. We live here because the view is beautiful. We live here because the land is fertile down near the river. We live here because our ancestors did. The canyon does not respond. It keeps widening inch by inch, rockfall by rockfall. Because while rivers cut down, canyon walls collapse sideways. Weather loosens blocks. Water infiltrates joints. Gravity pulls. A slab peels off and crashes to the bottom, where the river chews it into smaller pieces and carries it away. That is the full system. Downcutting plus widening plus transport, and if you listen for long enough, the canyon has its own quiet soundtrack. Not music, more like a building settling, a faint click of pebbles, a distant rattle of rockfall, wind moving through ledges like breath through teeth. It is cozy in a geological way, the kind of cozy that comes from knowing the planet is always doing something, even when you are not. And speaking of the planet doing something while you are not watching, you remember that water does not always arrive as a river. Sometimes it arrives as a sheet. You stand on a wide plain after a storm. The ground looks flat, but it is not. It has microslopes, tiny dips, shallow channels you would not notice until water takes them seriously. The rain does not soak in fast enough. Maybe the soil is compacted. Maybe it is clay. Maybe the land was baked hard by sun, so the water runs. Sheet flow, geologists call it. When water spreads thin and wide, it looks gentle, like a reflective skin moving across the land. But it is an efficient thief. It picks up fine particles first. Silt and clay, the stuff that makes soil fertile, the stuff plants depend on, the stuff humans like to farm. The water carries it away, and when the water slows, it drops it somewhere else, often in places you did not plan. This is why slopes degrade, why hills soften, why gullies appear seemingly overnight after heavy rain. A small channel deepens, concentrates flow, cuts faster, becomes a scar you cannot ignore. And humans respond the way we always do. We build little barriers. We dig ditches. We plant cover crops. Sometimes it works. Sometimes it just changes where the problem lands. Because water is persistent, and it is not sentimental. Then you notice a different kind of quiet work. A hillside that looks stable, until you see the subtle curves in the ground. A slump, a landslide, a slow mass movement. Not every landslide is a dramatic wall of debris. Many are just the ground creeping downhill over years, millimeters at a time. Bending fence posts, cracking foundations, tilting trees, into strange shapes. Geologists call some of those trees pistol butt trees because the trunk curves before rising straight again. In human terms, it is the hillside quietly rearranging your property lines. The trigger can be rain saturating soil, adding weight, reducing friction, or an earthquake shaking loose what was already unstable, or a river undercutting the base, or humans cutting into a slope and pretending it will behave. Congratulations, you have discovered that dirt has a breaking point. And when the ground finally moves, it does not ask permission. It follows gravity and water and the weakest plane. That is the theme again. The weakest plane wins. You drift away from slopes and canyons and slides, and you find yourself thinking about the opposite of cutting down, building up. Because the planet does not only subtract, it also deposits. You arrive in a place where water slows. Maybe it is the inside bend of a river. Maybe it is the mouth of a river entering a lake. Maybe it is a shallow sea where currents lose energy. The water drops its load because it has to. The heavier grains settle first, then finer ones. Over time, layers form. Thin beds of sand, thinner beds of silt, clay draped like a veil over everything. This is sedimentation, the quiet accumulation of future rock. Each layer can record a season, a flood event, a drought, a volcanic ash fall that drifts in from far away and settles like gray snow. And if the sediment gets buried, compacted, cemented, it becomes sandstone, shale, limestone. The loose becomes solid again. It is almost funny, in a tired way. The planet turns rock into sand, moves sand around, and then turns sand back into rock. Recycling, but without the moral victory. You stand on a broad, flat plain that used to be underwater. You can tell by the grain, by the fossils, by the way the layers lie. This plain looks safe. It looks easy. It looks like the kind of place humans love because it is flat and cooperative. But flat land is often just young land, newly deposited, still settling, still compacting. And somewhere beneath it, water is moving through pores, dissolving some minerals, precipitating others. Even here, the ground is not finished. You might think this is the part where we return to the sea again, because everything eventually returns to the sea. But not always. Sometimes the water never makes it out. Sometimes it is trapped. You step into an inland basin, surrounded by higher land, a place with no outlet to the ocean. Rivers flow in, but nothing flows out, except evaporation. These are endorheic basins. Though you do not need the word, you can feel the concept. A bowl, a catchment, a place where salts accumulate because water leaves and minerals stay. This is where you get salt lakes, salt pans, playas. This is why some lakes are so alkaline, so bitter, so hostile. The basin is a trap, and water is the delivery system. You can imagine the slow concentration. Each year, rivers bring in dissolved ions, sodium, calcium, sulfate, carbonate. The lake breathes water out into the sky, leaving the ingredients behind. Over centuries and millennia, the chemistry shifts. The water becomes denser, more mineral. The shoreline becomes crusty, bright. And again, humans see a resource: salt, borax, lithium brines in some basins. A modern treasure that makes people rush in with pumps and promises. We treat these ancient chemical soups like bank accounts. The basin does not care. It keeps concentrating. And then, because the planet likes variety, you move to water that does not sit on the surface at all. You go underground. Not in a cave with dramatic stalactites at first, just into the idea that beneath your feet, in many landscapes, there is a hidden plumbing system. Rain falls, seeps into soil, percolates through fractures. It travels through pores in sand and gravel, through cracks in bedrock, through layers that can carry it, called aquifers. Water underground moves slowly, sometimes painfully slowly. A few meters in a year or less. It follows pressure gradients. It follows permeability. It follows the path that lets it exist, and as it moves, it dissolves rock. Not quickly. In limestone landscapes, this becomes a whole architecture. Limestone is mostly calcium carbonate, a mineral that does not mind dissolving in slightly acidic water. Rainwater picks up CO2 from the air and from soil, becomes weak carbonic acid, and begins its quiet work. Over time, fractures widen. Tiny cracks become channels. Channels become caves. The surface above can collapse into sinkholes when the roof gets too thin. This is karst terrain, a landscape full of hidden voids and sudden holes. You might be walking across a pasture that looks normal, and there is a cavity below you the size of a house. Nothing dramatic, just absence. You are standing on a roof you did not inspect. Caves are the inside version of erosion, water carving, but in darkness. And the decorations inside caves, stalactites and stalagmites, are not carved. They are built. Water dripping from the ceiling carries dissolved calcium carbonate. When it enters the cave air, it releases CO2 and deposits a tiny ring of mineral. Drop by drop, a stalactite grows downward. On the floor, the drips splash and deposit their load upward, building stalagmites. Eventually, if the cave has enough time and enough patience, the two can meet and form a column. It is slow construction, the opposite of collapse, and it depends on steady conditions. The cave is an archive again, recording climate in mineral layers. But caves also remind you of the practical side. Water that disappears underground can reappear somewhere else as a spring, sometimes a powerful one. A river can vanish into a sinkhole and emerge kilometers away, as if the landscape has learned a magic trick. Humans build wells into aquifers. We drink the water. We irrigate fields. We pull it up faster than it refills in many places because we are impatient and the water is old. In some deserts, groundwater was stored during wetter climates thousands of years ago. Fossil water, essentially. When you pump it, you are drinking the past. The aquifer does not refill on your schedule. It refills on its own, which might as well be never from a human perspective. So underground water gives life and then quietly leaves you with an empty space. And speaking of empty space, you return to the surface and you feel the planet's interior again, not as a threat, but as a constant background warmth. Because the same heat that drives volcanoes also drives something else you rarely picture clearly: convection. Deep in the mantle, rock behaves like an ultra-slow fluid over long time. Hot material rises, cool material sinks, not because it wants to, but because physics insists. This churning is the conveyor belt for tectonics. It pushes plates apart at ridges, It helps pull them down at subduction zones. It drags continents across the globe like sleepy furniture rearrangement. You cannot see convection, but you can see what it produces. Rift valleys, mountain belts, chains of volcanoes, trenches so deep they swallow sunlight. And because your mind has already been sitting near rifts and volcanoes, you drift toward the other major tectonic mood, compression. You stand at the foot of a mountain range born from collision. Not a single volcano, not a single uplifted block, but a whole belt of folded rock. The strata are bent like wrinkled carpet. Layers that were once horizontal seabed are now tilted, even vertical, because plates pushed together and had nowhere else to go but up. This is how you get the Himalayas, though you do not need to say the name to feel the concept. Two continents colliding like slow vehicles, except the vehicles are the crust and the airbags are mountain peaks. Compression thickens crust. Thick crust floats higher on the mantle, like a thicker piece of wood floating higher in water. This is isostasy, the balancing act of the lithosphere. In human terms, it is the crust trying to find a comfortable position, failing, and trying again. Mountains rise, and while they rise, they erode. Rivers cut into them. Glaciers carve them. Landslides pull them down. The range is both growing and shrinking at once. That is why the most dramatic mountains are often the youngest, not young in human years, still ancient, but young in geological terms, not yet lowered into gentler shapes. You can picture peaks so sharp they look cruel, ridges like knives, valleys so deep they trap cold air, rock faces that shed avalanches regularly, because gravity does not care about scenery. People live in these ranges anyway. They terrace slopes. They graze animals. They build roads that cling to cliffs. They dig tunnels through rock because going around takes too long. And every winter, snow loads slopes until something gives. Avalanches release. Rock falls happen. Rivers swell with melt. Mountains are beautiful, yes. They are also unstable architecture. And once the mountain has been chewed down into sediment, you are back to the earlier story. Rivers carry it, basins fill, deltas build, coasts move. The loop is endless, but the loop is not smooth. It has pulses, and one of the biggest pulses the planet has, the one that reshapes everything without asking, is climate. Not daily weather, not the mood of a week, the longer shifts, the ones that change where deserts sit, where forests grow, where ice accumulates. You have already spent time near glaciers. Now you step back and look at them as a planetary system. During ice ages, massive ice sheets spread across continents. Not just mountain glaciers, but thick blankets of ice that covered large portions of North America and Eurasia. Ice sheets are not just cold, they are heavy. They press the crust down. They redirect rivers. They grind bedrock and dump till. They reshape drainage basins like a hand moving sand in a tray. When they melt, sea level rises globally because water returns to the oceans. Coastlines shift, continental shelves drown, new bays form, old land bridges vanish, and when the weight lifts, the crust rebounds slowly. That rebound can still be happening now in places once covered by ice. So the world you live on is still adjusting from the last major glaciation, like a mattress slowly rising after someone finally got up. That is a comforting image, in a way. The planet has memory in its posture, and the melting also leaves behind a particular kind of landscape, kettle lakes, where blocks of ice were buried in sediment and later melted, leaving holes that filled with water. Eskers, long winding ridges of sand and gravel deposited by streams flowing under ice. Drumlins, smooth hills shaped by ice movement, aligned like a brushed pattern. If you fly over these regions, you can see the ice's handwriting, but on the ground, it feels like gentle rolling terrain, dotted with lakes, calm and pastoral, which is how the planet hides its more violent chapters. It lets grass grow. Humans settle these glaciated plains. We farm them. We build on them. We rarely think about the fact that the soil is glacial debris, scraped from somewhere else, dumped here in a hurry. Sometimes, that debris includes boulders the size of cars, erratics, dropped far from their source, a granite boulder sitting in a landscape of limestone, like a misplaced object. It is misplaced. The ice moved it, and when you start thinking about ice-moving objects, you naturally think about the other mover people underestimate: wind. Not the breeze you enjoy, the wind that transports dust across continents. Fine particles, lifted from deserts, can travel thousands of kilometers, crossing oceans, settling on ice sheets, fertilizing rainforests, feeding plankton blooms in the sea. Dust is not just dirt. It is nutrient delivery, iron, phosphorus, trace elements that life needs. The planet runs on these tiny exchanges, so even a desert is not isolated. Its emptiness is exported, and when dust settles on snow and ice, it darkens the surface slightly, absorbing more sunlight, accelerating melt. Everything touches everything else, eventually. Which brings you back to the ocean, not as a shoreline, but as a system. You float above it in your mind, watching currents move like slow muscles. The ocean is not a bowl of still water. It circulates because of wind, because of Earth's rotation, because of differences in temperature and salinity. Warm water tends to be lighter. Cold water tends to be denser. Salty water is denser than fresh. So where water cools and becomes salty enough, it sinks, driving deep currents. This is thermohaline circulation, a mouthful of a term. In human language, it is the ocean's slow breathing, moving heat around the planet. That movement shapes climates. It makes some coasts mild and wet, others cool and dry. It influences where deserts form, where storms track, where fisheries thrive. And it also interacts with coastlines again, because waves are only part of coastal erosion. Sea level itself is not just about meltwater. It is also about the shape of the ocean basins, which is influenced by plate tectonics. When mid-ocean ridges are more active and higher, they displace water, raising sea level. When ridges cool and sink over time, they make more room, lowering sea level. So sea level changes can be driven by ice, by temperature, and by the slow rearrangement of the seafloor. You can feel the scale of it. Nothing is fixed. And if you move down into the sea, the bottom is not flat. It is ridges, plains, trenches, seamounts. Mid-ocean ridges are volcanic mountain chains. Underwater, where new crust forms, lava erupts, cools, cracks, becomes basalt. Hydrothermal vents form, where seawater circulates through hot rock and emerges loaded with minerals. Around those vents, life clusters. Not because the sea is kind, but because chemistry provides energy. Bacteria oxidize sulfur compounds. Larger organisms feed on them. Entire ecosystems run without sunlight. It is the Danakil logic again, but underwater. Life that does not need your definition of normal. Trenches, on the other hand, are the ocean's deepest wounds, places where one plate bends down and subducts beneath another. Earthquakes happen here. Megathrust quakes, the ones that can displace the seafloor and send tsunamis across oceans. Tsunamis are not regular waves. They are long wavelength pulses, moving fast in deep water, barely noticeable at sea, then piling up near shore as the water shallows. The shoreline sees the result as sudden, unstoppable flooding, the ocean arriving with all its stored momentum. Humans build along coasts anyway, because coasts are useful. Ports, trade, fishing, beauty. We treat the edge of a dynamic fluid basin like it is a stable address, and the ocean occasionally reminds us that it has a longer claim. But your mind does not stay on disaster. It returns to process, because process is what the planet does most of the time. You think about how sand moves along a beach, how dunes migrate inland, how barrier islands form. Barrier islands are long, narrow strips of sand parallel to shore, built by waves and currents. They protect mainland coasts by absorbing wave energy. They also migrate landward over time, rolling like slow carpets as storms overwash them, pushing sand from the ocean side to the land side. People build houses on barrier islands. You can guess the rest. The barrier island does not care about property values. It cares about sea level, storm frequency, and sediment supply. And sediment supply depends on rivers, which can be trapped by dams. So humans, by controlling rivers, can starve coasts of sand, causing beaches to shrink. We solve one problem upstream and create another downstream. The planet watches, patient as ever. Then you leave the coast again, because the outline of this journey keeps pulling you back inland to dryness. Deserts, yes, but not only hot ones. You step into a cold desert where air is dry because cold holds less moisture, and precipitation is scarce. The ground can be gravel, rock, maybe permafrost beneath. In such places, water still shapes land, but it does so in brief seasonal events. A short thaw, a melt pulse, a little stream running over frozen ground, unable to infiltrate, carving channels quickly. Permafrost, ground that stays frozen for at least 2 years, locks water in place. It makes the surface behave strangely. When ice-rich permafrost thaws, the ground can collapse, forming thermokarst, pits and ponds and uneven terrain. It looks like the land is melting, because it is, but melting from within, losing its ice scaffolding. Infrastructure in permafrost regions is a comedy of engineering. Roads buckle, buildings tilt, pipelines need special supports. People try to keep ground frozen under houses with thermosiphons, passive cooling tubes that pull heat out. Congratulations, you are fighting the seasons with plumbing. And as climate warms, permafrost thaws more, releasing carbon dioxide and methane trapped in frozen soils. That adds to warming, a feedback loop. The ground becomes both victim and participant. Again, nothing is isolated. Then your mind slides to a different kind of dry place. a desert next to an ocean. It feels like a contradiction. An ocean should mean moisture. Moisture should mean rain, but you can stand on some coasts and feel the air bone dry, the land barren, dunes and gravel stretching inland. Why? You raise the question and you let it sit there for a while, because the answer is not one thing. The planet rarely gives one thing. Sometimes a cold ocean current runs along the coast, chilling the air above. Cold air holds less moisture, and it tends to be stable, resisting the uplift needed to form clouds and rain. Fog can form, low and thick, but rain stays scarce. The Atacama in Chile, the Namib in Africa, places like that. Coastal deserts shaped by cold currents and atmospheric stability. Mountains can also help, standing inland, forcing moist air to rise on one side and drop rain, leaving dry air to descend on the other side. A rain shadow. The downwind side becomes arid, not because the ocean is far, but because the mountains stole the moisture first. So deserts can exist not because water is absent, but because it is intercepted. And fog in coastal deserts becomes a strange substitute. Plants evolve to catch it. Some have leaves shaped to collect droplets. Some rely on fog drip. Beetles in the Namib climb dunes in the morning, angle their bodies, condense fog on their backs, and drink it. Life doing less. Again, life using what is available, not what it wishes for. Humans do it too. Fog nets, mesh panels that harvest water from mist, producing small supplies in villages where rain is unreliable. It is a humble technology, and it fits the landscape. The planet provides a thin trickle, and people learn to accept the trickle. Then, because this is a bedtime geography story and not a motivational poster, you remember that deserts also preserve. Dry air and sparse vegetation mean less decay. Ancient footprints can last. Old roads can remain visible. Geoglyphs scratched into desert surfaces can survive for centuries. In some deserts, the surface forms a desert pavement, a layer of stones protecting finer sediments beneath. Wind removes the fine materials slowly, leaving pebbles behind, like the land has been swept. That pavement can stabilize the surface, making it resistant to further erosion, until something disturbs it. A vehicle, a construction project, a careless path. Then wind can lift the exposed fines, creating dust storms. The pavement was armor. Remove it, and the soil bleeds away. So the desert is both fragile and resilient, depending on what you disturb. And because you have been thinking about armor and exposure, you drift back to volcano country, but you take a quieter path this time. Not eruptions, not lava fountains, just the slow cooling of volcanic rock into soil. Basalt weathers into clays rich in iron and magnesium. Volcanic ash weathers into fertile soils too, often holding water well. That is why you get dense agriculture near volcanoes in many parts of the world. Java, parts of Italy, Central America, people living on slopes that can bury them. Because the soil is generous, they build traditions around the mountain. They name it, they offer ceremonies, they track its moods. The mountain does not care about ceremony, but it does have patterns. Volcanologists watch seismic swarms, ground deformation, gas emissions, thermal anomalies. They try to read pressure changes in magma systems. It is like trying to predict when a tired person will finally snap. You can see signs. but the exact moment is always uncertain. Some eruptions are phreatic, steam-driven, when water flashes to steam explosively. They can happen with little warning because the trigger is a pressure change or blocked vent, not necessarily new magma rising. Other eruptions produce ash clouds that drift, grounding plains, dusting cities. Ash is not soft like fireplace ash. It is pulverized rock, sharp and abrasive, bad for lungs, bad for engines, bad for everything that spins. But ash also becomes a layer in the geological record, a timestamp, a thin gray line in sediments that says, on this day, the mountain exhaled. And in that sense, volcanoes are again archivists, writing in minerals and glass shards. You can let that thought settle. The planet writes constantly. Even trees write in their rings. Even corals write in their bands. Even lake sediments write. Varves, annual layers of light and dark. Deep time is full of diaries. The problem is that humans are not patient readers. Then, because you cannot stay in heat forever, you drift back toward cold again, toward ice, but with a different focus. You stand at the front of a glacier where it meets the sea, a tidewater glacier. The ice face rises like a cliff, blue and white, streaked with gray debris. The ocean laps at it, small waves against a wall, and the glacier is tense, cracked, unstable. Calving happens when chunks break off and fall into the water. Sometimes small pieces, sometimes massive slabs that slam into the sea and send waves rolling outward. It sounds like thunder. It feels like a door shutting in a cathedral, yes, but you have already heard that in your mind. Now you notice the aftermath instead. The water becomes crowded with ice, brash ice, small fragments, larger bergs drifting, rolling as they melt. Each iceberg is fresh water stored on land, now returned to the ocean. And when icebergs melt, they release sediments trapped inside, fine rock, flour, gravel, even boulders, dropping into marine sediments. Another layer, another record. Glaciers also affect sea level indirectly through isostasy. When they melt, land rebounds, changing relative sea level locally. A coast might emerge, forming new beaches and raised marine terraces. Old shorelines, now stranded above the waves. If you walk along such a coast, you might see a flat bench cut into rock, lined with old shells. That bench was once at sea level. Now it is a step above. The land has risen, or the sea has fallen, or both. The planet does not label which. It just leaves evidence. And evidence brings you gently to the idea of time again. Not as a conclusion, not as a grand final thought, but as a practical tool. Time is what makes small forces large. A single raindrop is nothing. A billion raindrops over centuries carve a valley. A single wave is nothing. A million waves over decades eat a cliff. A single grain of sand is nothing. A dune made of trillions of grains can bury a road. A single winter is nothing. Thousands of winters build an ice sheet. So when you lie there listening, letting your mind wander, you are doing something compatible with geology. You are slowing down. You are matching the pace of a planet that does not sprint. And still, there are places where the Earth's pace feels faster not because time is different, but because the processes are exposed, close to the surface, impossible to ignore. You return, briefly, to the idea of rifting because the Danakil started this whole mood, a continent pulling apart. In some rift zones, you can see fresh basalt flows so new they are barely weathered. You can see fissures opened by dike intrusions, magma forcing its way up like a wedge. In Iceland, for example, rifting happens above sea level, making it visible. You can walk between plates across a cracked landscape where the ground is literally widening over time. Not widening enough to watch in an afternoon, but widening enough that people measure it with instruments and feel quietly uneasy. Rift valleys can also fill with lakes, long, narrow basins. If the basin is deep and isolated, the lake can become stratified, with different layers of water not mixing well. In rare cases, deep lake waters can accumulate dissolved gases, like carbon dioxide, released from volcanic sources below. If something triggers mixing, the gas can erupt from the water. Suddenly, a limnic eruption. Lake Nyos in Cameroon did this in the 1980s, releasing a cloud of carbon dioxide that flowed downhill and suffocated people and animals in nearby valleys. It is one of the strangest hazards on Earth, a lake that asphyxiates. Congratulations, you have found a body of water that can exhale. The reason the gas flows downhill is simple. Carbon dioxide is heavier than air. It hugs the ground, fills low spots, displaces oxygen. It is another reminder that danger is not always loud. Sometimes it is invisible and patient, like everything else. And because hazards like that are too sharp for bedtime if you stare too long, you let your mind slide to something quieter again. A plain of basalt, cooled lava forming columnar joints. The rock cracks as it cools, contracting, making hexagonal columns like stacked pencils. Giant's Causeway in Northern Ireland is famous, yes, but the process is widespread. You can stand among basalt columns and feel the strange order, nature doing geometry without asking. Cooling rates controlling crack patterns, the columns forming perpendicular to the cooling surface. It is tidy, almost comforting, in a world of messy erosion. But even basalt breaks down. Water enters joints. Freeze-thaw pries blocks loose. Plants root in cracks. The columns topple eventually. Order becomes rubble. Rubble becomes sediment. Sediment becomes rock again. The loop continues. And speaking of loops, you return to coasts once more, but not to cliffs or beaches, to estuaries. An estuary is where a river meets the sea, and fresh water mixes with salt water. It is a place of shifting salinity, shifting tides, shifting sediments. Mudflats form here, wide, slick surfaces exposed at low tide. They look empty until you realize they are full of life. Worms, clams, tiny crustaceans, birds feeding in the shallows. The mud is fine sediment delivered by rivers and trapped by gentle wave energy. It accumulates, builds marshes. Salt marsh grasses colonize, slowing water, trapping more sediment. Marshes are coastal buffers. They absorb storm surges. They filter water. They store carbon in their soils. Humans drain them, fill them, build on them, because flatland near water is always tempting. Then storms come, and the sea reclaims the space, and we act betrayed. Estuaries are also navigational, channels shift, sandbars move, dredging becomes a constant maintenance chore because the river and tide keep depositing new sediments. A port is a promise to fight sediment forever. And since your mind has been drifting through these fights, you start noticing a pattern in human settlement. We build where the planet is actively working. Along rivers, because water and transport and fertile soil. Along coasts, because trade and fish and moderate climates. On volcanic slopes, because rich soils. In deltas, because flatland and agriculture. In arid basins, because minerals. We choose the dynamic zones because they are productive. Then we complain about the dynamics. It is very on brand for us. But none of this is moral. It is just how organisms behave. You are an organism too, listening in the dark, trying to find comfort in a world that shifts. And you can find it not by pretending the earth is gentle, but by accepting that it is consistent. Water flows downhill, hot rock rises when it can, cold air sinks, salts accumulate where water evaporates, waves return, ice creeps, wind transports what is loose. Given time, everything moves. And because you have time tonight, or at least a few quiet hours, you let yourself settle into one more landscape, one more slow process, without treating it like a finale. You step into a high plateau where the air is thin. The sun feels close, not warmer necessarily, but sharper, because there is less atmosphere to soften it. The sky is a deeper blue, almost dark. This is where weathering can be intense even without much rain. Ultraviolet light breaks down surfaces. Temperature swings crack rock. Wind scours exposed ridges. If the plateau is high enough and cold enough, you might find paraglacial features, patterns in the ground created by freeze-thaw cycles. Stone, circles, stripes, polygons. The soil sorting itself as ice lenses form and melt, pushing stones outward and upward in slow pulses. It looks designed. It is not. It is water-changing state, expanding, contracting, moving grains like a patient hand. In some places, you see solifluction lobes, slow flows of saturated soil over frozen subsoil, creating gentle tongues down slopes, the land creeping again, always creeping. And somewhere nearby, a river begins again, fed by snowmelt, carving, carrying. The planet does not stop cycling because you are tired. It cycles because it cannot do otherwise. So you let the images keep coming in a steady rhythm, not as a highlight reel, but as a continuous map that rewrites itself softly. A river splitting into braids over a gravel bed because there is too much sediment and not enough stable bank. Braided rivers, wide and shallow, shifting channels like restless fingers. They are common near glaciers, where sediment supply is high. They are hard to build bridges over because the channel does not respect your design. A meandering river, the opposite, stable enough to carve sweeping loops, building point bars, cutting banks, migrating slowly across a floodplain. An alluvial fan at the mouth of a canyon, where a steep stream exits mountains and loses energy, dropping sediment in a fan shape. Fans can look safe, dry most of the time, but when a rare storm hits, debris flows can surge down thick mixtures of mud and rock, moving like wet concrete. They can bury roads and homes built on the fan, because the fan is built by those flows in the first place. Congratulations, you built on the evidence. And the planet keeps offering these lessons, not because it wants to teach you, but because physics. You can stay with that for a while, letting the repetition become soothing instead of threatening, because repetition is what makes geology feel like a bedtime story. Not a story with heroes and villains, but a story with habits. And the next habit your mind drifts toward is the way the ground can hold water, then suddenly refuse. You picture a drought, not just a hot week, but a season, a year. Rivers shrink, reservoirs drop, soil dries and cracks, plants close stomata to conserve water, dust rises more easily. Then, when rain returns, the first storm can run off instead of soaking in. Dry soils can become hydrophobic, especially after wildfire, repelling water. The water races over the surface, eroding quickly, causing flash floods even after drought, so extremes can connect. Dryness setting the stage for sudden flow. Again, the planet likes contrast, and you can feel how climate and geology intertwine. The same landscape, under a different climate, becomes a different machine. A river in a humid region meanders and builds wide floodplains. A river in an arid region can be ephemeral, dry most of the time, then violent. A glacier valley in a cold climate holds ice, grinding. In a warmer climate, it becomes a lush trough with a small river that looks innocent. A coastal cliff in a stormy latitude erodes faster than one in a calmer sea. So when you look at any landform, you are looking at both rock and weather, both structure and climate, both the bones and the skin. And you are looking at time. You keep drifting through it all, letting the planet's indifference be the comforting part, because it means the rules do not change based on your mood. Water will keep moving sediment in the dark. Wind will keep lifting dust off dry ground. Waves will keep returning, practicing the same motion. Ice will keep creeping where it still exists. And deep below, heat will keep rising, searching for cracks